now. All right, so we have zinc solid plus oxygen in the air, and that's going to form zinc oxide. Okay, so it says suppose that you have 4 atoms of zinc and 4 molecules of oxygen gas, and that reacts to form zinc oxide. So we're going to draw 4 atoms of zinc not touching because they're individual atoms, right? And zinc up here doesn't have a subscript by it, see? So it's just single zincs. And then I'll do blue for oxygen. Oxygen, there's 4 molecules of oxygen gas. So do you see oxygen is O2 with a subscript? So we're going to do 4. So there's 1, 2, 3, 4. 4 molecules of oxygen gas. Okay? That's what we're starting with. Our recipe, though, is up here. According to our recipe, when we want to make our product, how many zincs do we need for our recipe?
1.
How many zincs do we need for our recipe?
2.
2. How many oxygens do we need for our recipe?
2.
How many oxygens do we need for our recipe?
4.
1. 1. Okay. So we're gonna take 2 zincs and we're gonna take 1 oxygen, and those guys are gonna go over here, right? So they're gone from here. Now they've transported over to that product side, and they're gonna make 2 molecules of the zinc oxide. So we have a zinc, and we have a zinc, and that's connected to an O, and that's connected to an O. So we have 2 molecules of zinc oxide, 2 products. Can we do this reaction again?
Oh, yeah.
Yes, we can. So again, we're going to need 2 zincs and 1 oxygen, and that gets magically transported over to the other side. So these guys are gone from here, and then we can make 2 more zinc oxides. 2 more. Oh, I like where you're going, Brandon. What happens to the leftovers? They just sit there. So are they in the after picture?
Yeah.
Yes, they are. Because they are unreacted. Maybe I'll say this. Did not react. They did not react. They are unreacted. Okay, so look at B. How many molecules of zinc oxide are going to be produced?
2.
How many molecules of zinc oxide are going to be produced?
4.
4.
Oh,
1, 2, 3, 4. 1, 2, 3, 4. 4 molecules of zinc oxide. So I'm going to put it right here. 4 molecules zinc oxide. Which reactant is in excess? Which one do we have a lot of? The O2, because we have it left over. So this is O2. And how many molecules of the excess are there?
2.
There's 2. Okay. So let's write down some definitions. See the limiting excess and theoretical yield right there? Yeah, let's write down some definitions. Okay. So, and then we'll do a wee bit of math as well. A wee bit of math. Okay, so limiting reactant. Which one, I didn't ask this, I should have, but which one is our limiting reactant?
Zinc.
The zinc. And why is the zinc the limiting reactant? It's what stops us from making more, because what happens to the zinc?
They're gone. Runs out.
It runs out. Okay, so part of this definition, so the limiting reactant is the reactant that runs out first, right? It's the one that runs out first. But here's the thing, how are we going to know that it's the one that runs out first? Well, there's no excess. How are we going to know that? Let's do some math, and I'll kind of show you on the math how we're going to know that. Okay, this is just like s'mores, everyone. So let's go back up to this picture right here. Okay, and instead of doing the picture, let's actually do numbers, right? So instead of saying 4 atoms of zinc, let's do 4 moles of zinc, because they're the same thing. You can have 6.02 times 10 to the 23 zinc atoms, and that's 1 mole, right? So you can have 2 of that, so that's 2 moles. So we're going to say that we're starting with 4 moles of zinc, because that's what we're given up here. Okay. And every time we run this reaction, how many moles of zinc are we going to need? 2. See that 2 right there? We're going to need 2. Remember the mole to mole problem? That's what we're doing right now. And how many moles of zinc oxide are we going to make? 2. So 4 times 2 divided by 2, that gets us the same number. So that's 4 moles of zinc oxide. Okay. Let's do the same thing for oxygen. It says we have 4 molecules. That means we can have 4 moles of O2. Okay. How many moles of O2 do we need to run this reaction? 1. So 1 mole of O2. And how many moles of zinc oxide are we going to produce? 2. So 4 times 2 is 8 moles of zinc oxide. So what this is telling us is that if we have 4 moles of zinc and all of this is used up, meaning that this is a limiting, we can make 4 moles of zinc oxide. And this is saying if we have 4 moles of O2 and all of this is used up, assuming that we have lots of this and all this is used up, we would be able to make 8 moles of zinc oxide. But we can't, one of them is a lie. Which one's lying? The oxygen one. Because we know from our picture how many moles of zinc oxide are we going to make? 4. So this is our limiting. Okay, that's our limiting reactant. So how did we know? What can we add to our definition right here? The limiting reactant is the one that runs out first. And how do we know that we have a limiting, which one is a limiting reactant? What are we looking at to know that this is the limiting? The amount of what? You're looking at the product. Yes. When we look at these 2 products, did the limiting make the most or make the least? The limiting made the least. Okay. So the limiting reactant is the reactant that runs out first, and it makes the least amount of product. And that should make sense, because if it runs out, we can't make any more of what we're making. So it will always make the least amount of product. Because if it's going to run out and we don't have any more of it, then we can't make any more of the product because it's out. Questions on that? Okay. Let's do excess reactant. So if limiting is the one that runs out first and it makes the least amount of product, what's the excess reactant? doesn't run out, it's left over. The reactant that doesn't run out. And how will we know based on the product for this one? Makes the most product. So in our case on here, the excess reactant was our O2, and our zinc was our limiting. I'll put those in parentheses. Yeah,
You have multiple excess reactants.
you can. Let's put that too. Can be more than one. The limiting is only one. Only one. So limiting, you can only have one of them. Excess, you can have more than one. Good question. So then our last thing we need to talk about is called the theoretical yield. Has anyone ever heard yield used for something more than like slowing down?
Yeah.
What else could it mean?
Baking.
Okay, yeah. Yep. The amount it makes. Yep. So that's what it means for chemistry too. In baking, they say like it makes it, the yield is this. That's how much it makes. Okay. So theoretical yield is how much product you're going to produce. And so is the limiting or the excess going to produce this amount of product? The limiting. So it's how much product you will produce based on the limiting reactant. So in our case, what was our theoretical yield for that? For our picture up here, 4 moles of zinc. So the 4 moles of zinc is our theoretical yield. So I'll put that in parentheses. Zinc oxide, I should say. 4 moles of zinc oxide.